Test, test. Can people hear me? You can hear on Zoom? Excellent.
All right. That should be good. Should this be pinned or somewhere?
Mind if I get the mic first? Yeah, you mind? Let's show up the, put up the current calendar. Kind of like going over a brief overview of what's going on in the class. Yeah. Yeah. How's everyone doing? Good. There's so few people today. Is it? It's optional. It's Friday. That too. Huh? Oh, it's nice out. There's something special going on tomorrow too, right?
Yeah.
Supposedly.
That we all
I've heard it's a holiday. Anyway, yeah, so from now on, all the lectures are going to be optional. We kind of want you to focus on your project 3 if you need to. Nevertheless, we're going to have a lot of cool topics that we go over the next few days, so please show up if you can. If you're watching on the recording, because there's not many people here today, then please show up for the remaining lectures. They're going to be fun. In any case, other than that, yeah, I think only project 3B is next, right? And that's due on Monday. After that, yeah, after that it's a single homework and it's the final. All right, so today is going to be our final software engineering lecture. So we'll be covering over video game design. And here to perform our lecture here is Circle, one of our TAs. And I think one of the head TAs for over the summer, maybe? I don't know. Maybe. We don't know. We're still trying to figure that out. Anyway, let's give it up for Circle.
Yep. Do I need to hold the mic when I'm talking? Or?
Yeah, and hang on.
Should I clip this? Or? Okay. Do I need to clip this or should I hold it?
Up to yours.
Okay. Because I feel like it might be better if I clip it. Because I'm going to be doing stuff with my hands. Okay.
All right.
Actually, let me just do this. Hi. Let me start sharing. I think it's not sharing, so I'm going to start sharing my screen. Oh, it is. Okay, that's good. Yeah. Hello. Hope everyone's doing well. Okay. Let's see. Here's the... Just turn that off. All right. So I'm Chen. I'm from China, and this is my 6th time TAing for this course. And I love all things game related. Also play game music at the Intermission Orchestra. I have my itch profile. These are some of my games I made. So today we're going to cover game development. And specifically indie game development. So if we think about what we did in the introductory CS courses, these actually all involve some sort of game building. In 61A, you did the game Hog. It's like a game of dice. And we did Ants. It's like a Plant vs. Zombie copy. And in 61B, we build these two games, 2048 and Build Your Own World. Now, you might wonder, why do we do games? You know, why is game development always like so crucial? We do these because games are fun, and we hope that the pleasure of implementing a game is actually going to be a motivation for you to learn programming further. So that's why we give you assignments that are on games. Now, let's say some of you, after you're finished with all the game building, think about, okay, what if I want to take a step forward and make this a hobby? So some of you then, indie game development might be a good fit for you. And this is what I'm going to discuss. So the word indie here means independent. And this will be contrast as if you're working with like game companies, you know, like Blizzard or Riot. There's a lot more freedom you can do, but it can still be very demanding because you need to set your own deadlines and manage your own work schedule. Now, we have a slide color background. we have those blue slides, and those might be useful for build your own world. And we have these white slides, and these will be important for future game development. I'm going to close that. Is it possible to close the black windows there? OK. I'll just see. OK.
Oh.
OK, let's see. Does the audio still work on Zoom or something? Can people still hear me in the back? OK, I probably just hold the mic because, yeah, it's a little bit tiring, but. So in Project 3A, Phase A and B, you created random worlds and you enabled player to move around the world using keyboards. And Phase C just involves adding new features to make it an actual game. And the key question is, how do you design a good game? Now, the key concept and the key rationale for making a game good is that you should engage the player. Or like, if you engage them too much, then you can say the game is a little bit addictive. One example here is Flappy Bird. How many of you have Flappy Bird or played it before? Yeah, that's like a lot of people. So in Flappy Bird, the player's action space is very limited, and there's just one action, which is to tap the screen. And when you tap the screen, the bird just flies up a little bit, and then it falls down due to gravity. Now, the tricky thing about Flappy Bird is that it's really difficult to time the clicks correctly, and you want to avoid all of these pipes and stuff. So one takeaway from Flappy Bird is that you want your game mechanics to be very easy to learn. For example, a very simple and not complex action space. But there should be something interesting in your game that makes your actions really hard to master. Now, you might have this question. So Flappy Bird is a very simple game, only one action space. What if my game mechanism is inherently complicated? It isn't very interesting if I just want a player to be able to do one thing. They should be able to do 4 things, 10 things. So you want a way to make the player learn the mechanisms gradually. So that's why most of you might have seen in some games that we have tutorial levels, which are explicit textual instructions given by the game. Now, they might be embedded in an actual level, so you might still have a task. But the game still tells you what to do. So the game will still tell you, you should activate this switch, or you should open this door or something. So here's a tutorial from Genshin Impact. As you can see, there are actually levels that let you to trigger some sort of a elemental reaction, but the game is telling you, OK, when Pyro meets Dendro, it triggers burning. And then basically, it's kind of like reading a textbook or something, just like a miniature version. Now, there's one issue with tutorial levels, although they're systematic. Players don't learn by reading text. So they learn by interacting with the world. So this is one thing you might have heard of when you're doing maybe your application essay for colleges or something, which is show, don't tell. So that's why we introduced a concept called an antepiece. So antepiece basically means that you have an innocuous task that precedes a very big challenge. And this task is going to hint you at how you could resolve that challenge. So let's take a look at the word hint there. The word hint doesn't actually mean the game tells you what to do, but you should figure it out. So there are no explicit verbal instructions, and the player should just figure things out. As another example, Portal 2. Yeah, so this lecture is going to have a lot of concrete examples from various games because each game just have different elements. I'll try to introduce the context for people who never played the game. Yeah. So in Portal 2, the player can place 2 connecting portals to transport themselves. And they need to use these portals to overcome obstacles. Now, here's one example level from Portal 2. So you actually have these platforms that's an obstacle. You want to go up here. Now, the height is designed so that the player cannot just jump on the platform. But then you will see that there is an orange portal already created for you. And then if you place a blue portal on the wall, actually anywhere, you can even place it on the floor, and you enter that portal, you're actually going to come out of the orange portal. And now this will actually have the height, and then you're likely going to have some velocity that puts you in a projectile motion, and that takes you on this platform. So the key idea here is that this introduces like a forward movement out of a portal across a gap to a place you couldn't reach. And this is some sort of a heuristic when you're playing the game. So if you notice like this panel here, this is a protruding thrust forward panel with an orange portal on it. And whenever you see something like this, you're going to think back to this level and what you did. So now it comes the real challenge. So here's like a room with like a larger gap and like a deep hole. Now this black platform here is quite narrow, and the player is likely to fall in the pit. And then they cannot go out unless they create a floor portal, because the game's rule is that, okay, these black surfaces, you cannot really create portals on them. You have to create them on the floor. And now this actually sets them up for the solution. So if they just jump in through that portal, they're going to come out of the orange portal. And this actually brings them back to like where they started. Now, if they look at this more closely, they'll actually realize something similar like to the previous level. We have this portal. And if they recall like what they did in the previous level, if you fall into another portal, that'll actually give you enough velocity to come out of this, and then that should like thrust you out from here. Now, if you jump into that blue portal intentionally, this is actually going to make you thrust it to the other side. So you go here, woo, and then you're on the other side. Yeah, so that's anti-piece. So let's see the time. Okay. So you've seen that anti-pieces help players to learn, but why would the player want to learn? So the key issue is that most people play games because they want to relax. They don't want to learn. They don't want to like do another like 61B stuff or gaming. So we want motivation. The player needs to be motivated to learn game mechanics. And that's when feedback comes in. It'll be somewhat similar to like what you see in psychology. It's like you have reinforcement and punishment. It's like the behaviorism thing that you did like to the rats to make them do some sort of behavior, like electric shocks or like food or something. Now, the first concept here is positive feedback. It's more like a reward. And basically, when you have positive feedback, the player does well, and then they'll gain items, abilities, such that it'll make their game become easier. Now, the opposite is also true. If they don't do well, they just don't get those items, so the game is kind of harder. Now, if the game becomes easier, they're more likely to do well, and this becomes like a self-reinforcing cycle. So some examples, in most of the multiplayer combat games, the more opponents a player defeat, the more resources they're going to get, and they can purchase more items, which enables them to defeat even more opponents. So some example games, League of Legends maybe. Now, here's a question for the audience. What are some problems if positive feedback is too strong in a game? Think about it like for maybe a couple seconds.
Forgot to turn on chat.
Okay. Okay. Oh, yeah, I'm just going to roll back to like so we were having these. So yeah, any answers here? What are some problems if positive feedback is too strong? Yeah, they're in the back.
The game gets too easy and boring.
Yeah, so the game gets too easy and boring. And that's exactly right. You know, if you're at the position where like you just don't have to do anything, and then you just win the game. And the opposite is also kind of true. You know, if you made some small mistakes in the beginning, what's going to happen? The game just becomes too hard, right? Because there's like the obstacle becomes even greater. So, just as he said, if positive feedback is too strong in the game, you know, players who are behind are very hard to catch up, and there's a lot of focus on early game decisions, and the leading players just like lead. There's no interesting things to the game. So we have like a contrary aspect called negative feedback. So when the player does well, the game actually becomes harder by giving them more challenging levels or like worse items. You know, things are just more interesting if you have a lot of people in the middle especially like if you're playing Mario Kart where you're having fun in your games, it wouldn't be really fun if like just one player is ahead of the game and then the rest of the player just like, just doing their thing or falling behind. Yeah, the racing game example, if you're the last place player, you actually have a higher chance to get boosting items, or you have like some weapons to knock out the leading players. Now, let's think about the mirror question here. What are some problems if negative feedback is too strong in a game? Yeah? Sorry, can you repeat that? So that's a great thought. Like, so you said like it's going to become too hard. So what I'm going to point out here is that when the player actually doesn't do that well, the game is actually trying to help them by making the game link kind of easier. So I wouldn't say it's necessarily like becoming too hard. Yeah.
There's no incentivation for you to get better.
Yeah, exactly. So there's no motivation for you to get better because even if you just don't do well, you can just rely on the game giving you good stuff. I think like some people just complain to me when they play League of Legends. When they win, the game tends to give them worse teammates, so they lose. And then if they lose, the game just gives them better teammates. So their win rate just stays at 50%, no matter like what the skills are. So if the player sees that, well, they're just not going to hone their skills. Now, one thing you might notice is that these type of negative feedbacks are actually better suited for party games, where like people shouldn't be judged on their skill or something. They just want to have fun together. So you might see Mario Kart have more of them. Whereas positive feedback is more like competitive games, maybe like StarCraft. Okay. And speaking of motivation, there's actually another problem. The player knows everything after a successful run, so the game just becomes very boring because you know all the tricks. So you need a variability of game experience. And there are a lot of ways you can do this. You can randomize each run by randomizing items, rooms, or you could just keep on adding new content. I put like some examples of games who tries to do that. This is a game where the rooms are like randomly placed. This is just like one possible configuration. The boss is like here. It could be somewhere else. This game is called Binding of Isaac. And here, there's Genshin Impact 4.6. Have like a new character, Arlecchino, added in. So these are two ways you can, make the player still engaged. Yeah. Let's see how we're doing on time. So what elements would you add to build your own world to make it a good game? So this is a time for people to discuss with your neighbors. Think about it for like a few minutes, and then let's try to share what people will try to come up, because this is actually part of like Project 3C. Yeah.
Don't worry. Okay. This is just talk. Wait.
I don't think there's.
Tennis can chat with Pass can chat with everyone too.
Okay. Okay. Cool.
Yeah. Okay.
Yeah. So I'm gonna try to. Oh. Hide floating control panels on the left. Let's see. Okay, that's full screen. Yeah, I guess I could just ask people to share. Actually, there's someone in the chat. Okay, that's good. I'm going to stop sharing it now. Yeah, Justin will be typing like some of the responses that people write, so you can all see. Does anyone want to share what they have? I'll also be checking like the Zoom chat if people have any ideas. Yeah. Yeah. In the back.
You could add an immersion concept, kind of like, for example, you could create a storyline, maybe.
Okay. So the concept of emergent like storyline, is that what you're suggesting? Yeah, that could be interesting. You know, you add some sort of a lore. Yeah. Do we have anyone else? Yeah. Yeah, enemies, obstacles, player needs to overcome. There. Oh, sorry. What system? Point system. Can you elaborate a little bit like more on how you would try to use that? Oh, yeah. Mm-hmm. Yeah, exactly. So point system, like you have like a score running thing. Good idea. Okay, we'll try to do like maybe one or two more. People have any? Yeah. Yeah, so you know, points just currency or money where you can purchase stuff. That could be interesting. All right, let's see. Do we still have any others? Okay, I think this is a good place to stop. These ones are really good ideas. They're definitely like somewhat different from the last time I did this lecture. So it's really interesting to see people contribute to this discussion. So we're now going to move on. Let's see. Let's do this. So I'm going to hide floating. So we're going to discuss the pipelines of making a game. And let's say you design those game mechanics like the ones you mentioned above. How would you actually turn it into the final product? Now, you'll need to work with a lot of different people on your team. You're going to be working with designers, artists or musicians, and you're going to be working with other programmers, and you're going to be working with testers. And there's also like a timeline for starting from a game and making it to an actual thing. So you're going to start with an idea, and then you're going to create paper prototypes, and then you create a minimum viable product, abbreviated as MVP. And then you iteratively improve your game by going through alpha, beta, and release. So I'll just explain like using Minecraft as an example, but the general process should be the same no matter what game you're looking into. So the ideation phase is a couple sentences or elements relevant to the game. And for Minecraft, this includes some of these rationales. So for Build Your Own World, it's actually kind of similar. The idea is like randomly generate a world with rooms and hallways, and you have an avatar that can move. Now, this is one of the games Minecraft is inspired by. It's called Infinite Miner. You have like block-based worlds. Now, we then have a paper prototype. So basically, this just presents the game on paper. And then the purpose of this is just for people to discuss all the ideas, and they can make changes quickly without actually writing any code. Because when you write code, you need to debug them, and changes take a long time. But if you write stuff in paper, you can just erase it and write up new stuff. So here are some example paper prototypes this is from the game Binding of Isaac. I don't think there are any Minecraft paper prototype lying out there. So you're going to actually think about like 1, 2, 3. What are the main mechanics? And you can change them if you just think those are not good. And then after a paper prototype, we'll actually be going into the MVP stage, where we develop a bare bones but still playable version of the game. So the purpose is to tell others that the idea works because it's been implemented into code. And this is what the MVP for Minecraft looks like. It's actually the earliest playable version of Minecraft you can see, but it's very bare bones. There are no other enemies, but they're just like these blocks. And as a note, given the time we give you on Build Your Own World, your game will likely top up at this stage. And then we have alpha. So the purpose of alpha is to show the game to a larger audience, and then including like maybe your friends, maybe other people you don't know, and then have them just do a play test and receive like feedback. So this is alpha Minecraft. Still missing a lot of the real features from the game, but you see we have trees, we have more advanced things from the base game. And then we have beta, and this will be a preliminary release to the public. So in alpha, your share like circle is limited to some people who you know, but if you're doing beta, then you might just post the link online, and then people who don't know you will just like click on that link and play the game. And then you see you have more varied biomes in Minecraft, and you have other fancy stuff. And then for full release is just at some point you decide that you don't want this game to be in beta anymore. You just want to announce to the public that this game is an official game. And the cutoff can be a little bit blurry. You can decide like at some point maybe you want to finalize the game details more, so you just put off. Or you could just like do it early and then release like version updates. So for Minecraft, this is when you can beat the Ender Dragon and beat the game. Now, after the final release, the game is still under active development, and it still receives updates. So when I started playing Minecraft, it was 1.4.7, but now it's already like 1.20 point something, and it's still going on. So you can see like the game is not a static product. It's something that you'll build on like more and more. Yeah, and we'll shift gears briefly into programmer perspective. But just before that, anyone has any questions? Let's see, do we have any questions? No. Okay. Okay. We'll be going on the programming stuff. So we talked about how games are made in general, like the pipeline things, but we didn't really talk about how we actually code them. And this is actually what it's more relevant to like 61B, because 61B is like a data structure course. So let's say the problem that we currently have is we want to design a build your own world with encounters, similar to encounter systems in Pokemon. So this is the Pokemon world. It looks kind of like a build your own world, but what an encounter looks like is this. Let's say you're walking randomly and then you trigger, it's kind of like a step on landmine thing. You suddenly enter into a battle and then some wild monsters appear and you need to engage in battle with them. So we're going to think about how we can implement this. So if we recall how the basic build your own world works, because we want to build our foundations, you would do this in a while loop. So process input, update universe, and render the current state to the user. Now you also want to wait a little bit until the next update, because you want the game maybe run at 60 frames per second or something. Now, about keeping the code clean. So in our build your own world with encounters, there are actually different scenes. You start at the main menu. When you press N, you go to the enter seed scene. And then when you press S, you go to the world scene. And then at some point, you randomly go into the encounter scene. So the problem is that each scene will have different things to update. So if you're in the world scene, you render blocks and process WSD. But if you're in the encounter scene, you don't want to render the world tiles because they're just not in the encounter. But you want to render the information that's pertinent to the encounter. So let's revisit our requirements, given that we've saw like those constraints. We want to make the game do different things in different scenes correctly. And we also want to enable us so that adding new scenes should be relatively easy. That means, you should code in a clean way so that you won't hate your past self. So how can we do this? I'll actually show people like 2 solutions that are attempts, but like have some shortcomings, and then I'll give like a solution that's, to my understanding, pretty clean. So this is the first thing that we have. We're going to have nested while loops. This could be like abstracted as their own function. Like I could have a title screen that has a while loop. I could have an enter seed that's a while loop. I could have a world movement that's a while loop. But something that we don't like about this is that if you want to create a new scene, you're going to actually add another nested while loop over here. And this actually hurts the readability because the more you indent, the more complicated your code becomes. And actually, it's not possible to switch back and forth between 3 scenes using these because you couldn't just ignore, like, after you're done with the innermost while loop, you couldn't just ignore that and then go to the outermost immediately. Now, here's a better approach, but it could still be improved. Let's say I have a string variable that represents the current state, and then I just put all these if-else branches to check, what is the current scene, and I just do different things accordingly. Now, for people in the chat or maybe this audience, what is like something that could be improved about this, or like what is something that's not optimal about this code, or not clean? Yeah.
It's doing a bunch of different equals checks every time.
Yeah, exactly. You do like a bunch of different equal checks every time. And just to elaborate a little bit on that, let's say you want to add a new scene. What would you do? What would you need to do here?
Add another if statement.
Yeah, you need to add another if statement. And that's something we kind of don't want because your game is just going to have if, else if, repeated 100 times. And that just doesn't look very clean. Yeah, so this is like the best maybe we can think of at the moment, but how do we actually tackle this problem? Well, I'm actually going to first introduce like conceptual tool, and then we're going to see how we can use this conceptual tool to tackle the previous problem of handling different scenes. So this concept is called a finite state machine, and it's used to manage a complex game with a lot of different scenes. And specifically for Flappy Bird, if you recall how the Flappy Bird works, you're going to start with the title screen, and then you're going to go to countdown, and you have 3, 2, 1, go, and then you go to the play state. And then once your game is over, you go to the score state. And then after you're done with the score state, you go to countdown state again if you want to play again, and then you just go back. Now, what sort of data structure does this remind you of that we've covered in this class? I heard someone say graphs, and that's entirely correct. This is a directed graph. So it is a lot like it. The vertices are just the states that the machine could be in. You have the title, enter seed, and then the edges are just the transitions from one state to another. So one example, if you're in the title and you push L, you should be able to load directly into the world. And then the machine could only be in one state at a time. So you'll need a variable to keep track of that. And that makes it different from a directed graph, because the directed graph doesn't have like a current state. Now, we're going to have a sequence of inputs / events that are sent to the machine. And then you can check if any outgoing edges from your current state have their transition conditions fulfilled. Now, that sounds like a mouthful, but I'll kind of like give some examples, and including code, like next slides. So we talked about general walkthrough of the finite state machine. Let's now take a look at how the build your own world with encounters could be modeled by. So you have the title, enter seed, world. So we have the N go to enter seed and S go to world. You also have the L directly loads into the world. And you have the exit game. And then let's say the user steps on like a coin door, and that brings them to a world full of coins. And then that's just an encounter. So that's another edge, and that's another scene. And then when the user collects all the coins, they're going to go to a game win scene. And then if the timer runs out, they're just going to go to a game over scene. So you're going to have a restart if you are in those states and you press like maybe your R for restart or something. So here's how you could potentially implement a finite state machine in code. So you're going to have like something that represents your current state machine. And then you're going to have your main game loop. So you read the input, you do some updates based on the input, and then you render to the user. Now, how would the state machine class look like? Well, the state machine class is going to look like this hash map with like a map from like, the different states to the actual game state objects. So you're going to initialize all the individual game states, and then you're going to have a current state. Now, the state machine is going to have an update method, which basically takes in, gets the current state and then calls the update of that state. And then there's just only one line there. And then the render is just going to call the render of that state. So it's pretty like bare bones, doesn't have anything. The actual stuff that's being implemented is the individual update and render methods. So if you have change state, well, change state needs like two things. You need to execute the exit function and the enter function of the target state. And then I'm just going to define like an interface of game state, and that has all like the pressed, render, enter, exit. So now if I want to add new game states, I could just implement that game state interface. Yeah, this was from last slides. If you have the world state, the update function could be like, move your avatar based on pressed. And then if you step on the door, you're going to call like machine.changeState into the encounter. And then the render is just going to draw the world. Now, public class encounter state, this is another game state. You're going to take in like the pressed. Now you're going to maybe move your avatar based on press, depending on what you want to do in your encounter. Like if the encounter has to do with characters moving around, then that could be possible. Now if you won the encounter, you're going to call another change state, and you're going to maybe go back to the world, or you can just go to the win stage. Yeah, and then there's another render method. Now, how does the game exactly know which update and render to call? Remember in Java we have this method overriding, where we actually see that the overridden method is run if we call that update method from there. You have different like states based on how you instantiate them. So Java is going to know by overriding to pick which one is the correct to run. Yeah. OK, so before we talk about game engines, any questions here? Someone in the back? Yeah, the question is, can we use state machines for the actual project in Project 3? And the answer is yes, because the general structure is like, that's like a really cool concept. The actual implementation details are up to you, but like the design idea is going to make like the stuff much cleaner. Yeah. Actually, I would be kind of pleased if someone decides to use a state machine to do all the scenes. Yeah. OK. If there are no more questions, let's do a time check. And then let's move on to the game engine part. Now, based on the discussion from Java, like you've seen before, coding games from scratch is really hard because it requires code that exists in most games. Like the scene transition thing, you're probably going to think about like, OK, because you have so many different games that have scene transition, you're probably going to have all the repeated code. Can we just like somehow abstract away all those like redundant code, also called boilerplate? And the answer is game engines. So one example is called Unity. And Unity is abstracted so well that you could develop games codelessly. And in Unity, everything that exists in a game is called a game object. Now, you can download game objects made by others, and you can drag and drop the objects in the Unity editor. This is an example of a Lego blocks world. And then what's cool about this Lego block is that when you attach this blue block to the platform, it'll enable the platform to move up and down periodically. So you don't have to write any code because the code that does this is already written for you. Now, even if you decide to write some sort of a code, the engine still abstracts a lot away from you. In Build Your Own World, you need to come up with class definitions for Java classes. But in Unity, you can just define like what are the sort of game objects that you want, and you can attach something called a script component to the game object you want to control. Now, this script, there are some rules for this script. And specifically, it should like inherit the mono behavior and then override these two functions. So you should define what the stuff, like what the object should do when it's been initialized, and you should define what it should do at every frame. And then Unity is just going to call those methods behind the scenes for you. Now, you might wonder, okay, what about scene transition? We talked about scene transition like maybe a few minutes before. How does Unity handle that? Well, Unity has a finite state machine that's running behind the scenes. And they actually provide you functions that you can use to change those things. So in the Unity editor, you can click on the file new scene to create a new scene for a game. You can define what the game objects need to exist in that scene. And you can actually tell them, okay, here's what you should do when the scene starts. Maybe like if this is your player, initialize like the health to like 100, set the score to 0 or something. And then, when you want to transition between the scenes, you just call this function called scenemanager.loadScene. Now, here's an example of a scene. Here's another scene. Here's a lose scene. And this is the code I've written for like these two parts. Yeah. Actually kind of like open up this Unity editor to see. So this is the camera object. It has like all the other stuff. You can see that there's a script. There's a script that does like the camera movement stuff, like how do you make the camera follow the player. And then this is your player. It has like, these are just for like the physics of the player, but then you also have a player controller script. And then, you can just define what scenes you have here. And here is just the very bare bones like lose scene. You're going to define that you have like some sort of like a canvas to draw on. And then you just say like you lose there. Yeah. And I can even like drag this player around to change its starting position, and it's going to start a little bit off-centered, but that's it. Yeah, so there's still some general tips about writing good code. For example, don't repeat yourself. So you shouldn't try to like make different variants of an enemy, but like you should just try to make one and inherit from that. If you have different versions of slimes, for example, you can just make 3 subclasses that all inherit from one superclass. You should also try to separate data from logic if you want to write games that are like relatively big. You maybe want to store them in a text file or somewhere else. Just don't like hard code in the game because like you're gonna have like a really long page of code that just has all the constants. I think it might make your code a little bit bloated. Also, you should learn to work with different types of assets, which are resources used in the games. So like images, audio, or 3D models. And you also need to know some algorithms. So for example, A-star pathfinding is actually used by zombies in Minecraft. And as a matter of fact, I think Project 3C has one feature that you can do, which is to implement some sort of pathfinding for enemies to chase, like the avatar. Something similar to that. And finally, don't repeat yourself. Okay, so we're not going to talk about game modding. It's another shift of gears. Let's say you don't want a dirty work of creating all like a brand new game, but then let's say I really love one of those existing games. I want to just modify the things that are going on it. And this is actually called game modding. It modifies the existing gameplay experience or just like adds new content to it. So one way is to add new levels. This is a music game called OS, where you just like click on those circles and then those slide bars in time. But then the game actually gives you a tool to add new beats according to like a song that you like. Now, Super Mario games also have like player-made level editors that you can drag and drop all the pipes, enemies, and stuff. Now, you can also choose to add new content using code. And I'm going to show like the Terraria code here. This is the mod I try to do. So we're going to try to create a sword called the Sword of 61B in Terraria. And it's going to deal 61 damage, now less than 61 because enemy has some defense. And it's going to show this flavor text whenever you hit an enemy. So how do I do this? Well, I'm just going to write a code that's like, a sword 61B that extends like some sort of a class. Now you might wonder, okay, how do I know it's these classes? How do I know it's not something else? And the answer to that is like you should read the documentation you found online, and that should tell you like what you should do. Now, we've talked about hacking into games, kind of, coding and stuff, or adding new levels. So some of you might actually wonder, is this like a legal thing to do? So in the actual beginning, most games don't have modding support, so it's actually not that legit. But then some people in the community really want to change stuff in the game. They got bored playing the base game, so they eventually reverse engineer the games, and then they created support for those mod support platforms. And then some game companies realized that gaming actually, like the game modding actually helps the original game because, we talked about this at the beginning of the lecture. If the player does a successful run, they just get bored. And specifically, the reason I still play Minecraft is because of mods. I wouldn't play like vanilla Minecraft runs because I've done them so many times. So eventually, modding just became semi-officially supported. And these are just some of the bottom lines you should be aware of. Don't mod a game if the developer bans it, and don't mod a game like when you're modding the game, don't release the source code. And for some games, the game companies just decided to release like an official modding support tool at the very start. Some example games are these. Now, as I mentioned before, the game companies and the game modders have some interesting dynamics because game developers are going to take away from good mods and add them to the game. So as you can see, this game called Binding of Isaac released its patch, and on the features it says the fan mod, the Binding of Isaac Anti-Birth integrated into game as official content. So you can see like those game developers really taking away from the community did for them, taking the good and then maybe leaving the not so good part. So this is really like a two-sided like relationship where you give something, you learn something. Yeah. Now another example is Super Mario Maker. So now we have a lot of players creating their own levels. So why don't we just create a game that's about making new levels? So that's Super Mario Maker. All right, so we're almost at the end of today's lecture, but as a summary of today's lecture content, we covered coming up with good game ideas. We covered the pipelines for making a game, so this is six-stage pipeline. And we covered writing code for games. We talked about coding games in Java and talked about Unity. And we also talked briefly about modding an existing game. So if you take a look at all these layers, at each layer, you're going to lose some of the freedom, but you're going to do less dirty work. If you're modding, you don't have to start anything from scratch. But the good thing about indie game development is that you can choose which layer you enjoy the most when you develop the game, because you're not constrained by deadlines or the company goals, so you can just do whatever you want. So therefore, I just hope you enjoyed this lecture. I hope you find this very helpful, and you would consider developing this as a hobby. Yeah, thank you, everyone. I'm now moving to questions. Yeah, any questions? Yeah.
Do you have any idea of how like the recruitment or application cycle is for like game development, for example?
Okay, so the question is, do I have any idea about the recruitment cycles or recruiting for game companies? I'm sorry, but I do not have like that knowledge about this because I'm just like an indie game developer. I do not work for like game company. So yeah, I do not have that knowledge. Yeah.
In that case, could you tell us about like how it's like to work as an indie developer yourself?
Yeah, so the question is, what does the life of an indie game developer look like? So honestly, this is something that I do like as a hobby. This is actually something I thought about. What's it like if you do things indie or on your side? It's kind of like running a startup or like, starting like a, like a sidekick. The key idea is that you're going to be responsible for your own work. It could be demanding, it could be not. You can always like pace yourself. I honestly think like this semester I probably wouldn't have that much time for game development because my coursework is like really tight and I have like grad school applications and stuff. So the thing about this is that you should pace yourself, and then it's your own work. If you do well, like it's your own thing, but then nobody else is going to take credit for that. So you need to be like fully responsible for all of your things. That's what I'm going to say. Like it really depends on you. Yeah. Q&A here. Terraria weapon mod was that simple? Yeah, so I'm gonna answer this question live. So this is actually kind of simplified, but Terraria weapon mod uses this tool called like tmod loader, where they actually have this like tutorial which you can read about, but they did provide like really good abstractions where you can like define all these attributes and then do that. I'm gonna link like actually not gonna link it, but you can search tmod loader on GitHub and they have a pretty good Wikipedia page you can read about. Yeah, but then tmod loader makes making mods in Terraria really, really simple. Any other questions? Yeah. Oh, yeah. So the question is, after you made a game, which platform would you use to publish it? And yeah, and then my first answer to this is something that starts with S, and that's Steam. So Steam is like my first go-to if we were to publish games. I think like the good thing is like players can, so first of all, like if you want your game to be somewhat monetized, like Steam has like some support for that. But also, you can have something called like I don't know what's that called. That's called a workshop or something. But you can actually support players to make mods to your own game by having a Steam workshop. Another good platform is called itch.io, which I actually kind of showed here. If I click on this, it brings me to itch. And then itch is a place where indie game developers can put their own games on there. Yeah. Played on tmod loader for 80 hours already, never even read that. I think it's gonna happen because like they're just like two different like roles we're playing. Like tmod loader has this page where like, okay, if I'm a player, read this. And like if you're a player, read this. If you're a developer, read this. So I think that's like totally fine. Like maybe like modding like sometimes just feels a little bit too much work for people. But yeah, I'm actually gonna open up the tmod loader GitHub page. Yeah, maybe like if you're interested, you can take a look at that. So yeah, if I click on I'm a player, it's just gonna tell you how to install tmod loader. But if you don't just want to play, there's like a bunch of tutorials, and I think it's pretty well written. Yeah, there are these guys over there. All right, I think that's all the time we have.